So is this visible now?
Yes, sir, it is visible.
Okay. So in the morning session, I talked about in general machine learning, then basically uh, applications of machine learning in industry and at various places, also why machine learning is important, and then how it is useful in industry and all those things. And then how preparation for AI and machine learning is going on all over the world for building the infrastructure and so on. So that is what I talked about in the morning session. Now in this session, I'll talk about what are the challenges and what is the future of this machine learning or AI related technology and so on. So let us talk about this one. So those who have worked in the area of artificial neural network or machine learning related area and so on, they might have experienced that, okay, as I told you that whenever you are training, there are two phases. One is training phase, another one is testing phase. And then whenever you are developing any algorithm and giving a training to that machine according to the algorithm, it takes a lot of time for to train that algorithm on testing database and training database and so on. And then for that, it requires a lot of memory as well as it requires a lot of time consuming, and number of iterations are also more and so on. So is it possible to develop a neural network which will require less memory and less data storage and which will learn very quickly? So because see, a number of iterations are increased and then that it becomes a hurdle. Otherwise in less iteration you don't get that kind of accuracy and so on. So if you want more accuracy, then you have to increase number of iterations and that becomes a hurdle. So we need to basically find out the correct architecture which will basically learn in a very less number of iterations, and it will be very effective, and it will find the facts very quickly. It will store those facts and seamlessly access them whenever is needed. So developing a neural network which will basically work on the less data, as well as it will require less memory for storage and so on. Then another challenge is that natural language processing. I told you that this is one of the hot area of machine learning or AI related. A lot of people are working in this area, but success is limited. So we need to work hard and develop the new algorithm in this field, and we need to go very close to the natural language processing with the help of AI and machine learning. So presently, success in natural language processing and understanding of language is very limited. And you know that in India itself, there are several languages available. Uh, and understanding truly all the languages by the computer is really challenging. And this is still massive challenge even for deep neural network to understand every language and so on. So presently we teach computers to represent languages and simulate reasoning based on that. So however, this has been consistently poor, so we need to develop the new algorithms which will really be useful and which will be more effective as compared to the earlier one. Third challenge, which is very, very important, is that as a human being, see, we are trying to mimic the human being in the machine by artificial intelligence and so on. See, there are some advantages of machine and disadvantage of human being. Like, for example, advantages of machine is that okay, you know that in grayscale image, you have the grayscales 0 to 250 grayscales are there. And if you basically create an image such that 256 by 256 image such that your first row, first column is having intensity equal to 0, second column is having intensity equal to 1, third column is having intensity equal to 2. So like that, where 256th column is having intensity equal to 255. Now, if you visualize this image, okay, you will see that image looks like gradually increasing the intensity. So from black to white. Now, if you point any two pixels, consider okay, nearby pixels, and if you ask the human being, tell me what is the difference between the gray shade of this point and this point, or this pixel and this pixel. For human being, it is very difficult to tell that one. Okay, because our vision system has limitation that we cannot distinguish all those 256 gray shades with our human eyes. Okay, then how many gray shades we can distinguish? So out of 256, hardly we can distinguish a couple of dozen or maybe up to 32 gray shades we can distinguish. Means if we make the 32 beans of all those 256 gray levels, like for example, okay, in one bean there will be several gray shades together, then another bean, and so like that way up to 32. So means 250 is divided by 32, so that many color shades will be there in one bean, and then another bean will be there. So in between that one we'll be able to basically distinguish the color shades. But between consecutive this one, it is not possible. We don't have that much capability for the human vision system. But this is possible in the case of computer vision system or machine learning algorithm to distinguish this one. The gray shades, like all 256 gray shades can be distinguished. Or same thing, like for example, if you extend in the color image, in the color image, you know that there are three planes. One is R plane, then G plane, and P plane. And in every plane, you have this one. Every pixel is represented with 8-bit. So for R plane, every pixel is represented with 8-bit. Then G plane pixel is represented with 8-bit, and then B plane. So for one pixel, there are three planes RGB, and total number of bits which are used for representing one pixel in a color image is 24. Now 24 bits are used. So how many shades are there? Color shades are there? That is equal to 2 raised to 24 color shades are there. Now 2 raised to 24 color shades means it is more than 16 million color shades. Now computer can distinguish all those 16 million color shades, but what about the human being? Human being cannot distinguish all those 16 million color shades. How many color shades? What research says? How many color shades with our eyes we can distinguish? Hardly 900 to this one. 900 to 1000 color shades we can distinguish. So in that distinguishing ability of human being is less as compared to the artificial intelligence or machine learning or computer vision system. But there are certain advantages of human understanding or human vision system or like that. What is that advantages? So first thing is that learning happens in the eye itself. In case of human being, see that interpretation, finding the colors or basically finding the edges, that happens in retina level itself. Whereas in case of artificial intelligence, when you are capturing the images with camera is analogous with your eye, but it does not give you what is the age or what is the color. It will just capture the image. So this first level information is not available or basically is not processed in case of camera, in case of or artificial intelligence. But in case of human intelligence, it is done at basically retina level, and then after that basically information is sent to the brain, and then brain processes it. So sometimes we take the decision not only on the visual data or visual this one, but we take the decision basically on the attention. So attention is another parameter which is widely or robustly used in the human decision making, and this is integrated along with the visual data, and this is missing in case of machine learning, or this is missing in case of artificial intelligence. So in artificial intelligence or machine learning, what we do basically, we take one thing at a time. Okay, we process it, and then after that we integrate it, and then we take the decision. Whereas we are totally neglecting the information about the attention, because this is not at all captured in case of machine learning or artificial intelligence. So here human this learning is better as compared to the machine learning. Now if you want to make machine learning or artificial intelligence truly like as a human learning, so in that case you have to integrate this attention factor also along with the other this one factors like as visual data and so on. So for machine learning to be truly realize its potential, we need the mechanism that work like as a human visual system to be built into the neural network, and this is one of the challenge to implement in the AI. Means basically we have to integrate the attention of the given scene and so on, so like that way. Fourth, this one challenge is that, as I told you, that difference between the machine learning and deep learning. In case of deep learning, number of layers are increased. See that this is the hidden layer 1, hidden layer 2, hidden layer 3, and so on. So these layers are increased, whereas in case of simple machine learning algorithm, only one hidden layer is there. Now, this complete structure gives you the feature extraction and classification. This one. It is combined together, and you get the feature extraction and classification, and this one. Most of the time, see, as I told you that in 2018 when I visited this SB conference, recently also we conducted an online challenge at SB 2021. This was held at France, but now this year it was totally online, so I conducted it from my home itself, that challenge, and we basically developed a new this one database on diabetic retinopathy, but now this is on multi-disease. So there are 45 disease database we have developed in last 2 years after IDRD, and now this is open for the research. This was basically we conducted the challenge at ISB 2021, which was organized in the France. Okay. So as I told you that in most of the medical problems, this deep neural network is used for training purpose or solving that problem, complex problem, and so on. And also I told you that in SB 2018, out of 800, near about 750 researchers were using the deep neural network for solving their problem. But it is found that many researchers are using this deep neural network as a black box. Okay, there are several architectures available in deep neural network, and then instead of understanding it correctly, people are using that as a black box and just giving the input, like as a huge set of millions of samples are given as an input. Your deep neural network is trained, and then finally you get the output, and this output is very correct. Like sometimes you get 99.5% accuracy, which is very close to the human being for solving the problem, complex problem, and so on. But how exactly this deep neural network works or learns the things, what are the output of every hidden layer and so on, that is totally unknown for the researchers. If it is known, okay, if researchers try to understand this deep hidden layers output and so on, it will be really useful for them to understand the architecture, as well as they can also make the changes so that if there is any deficiency, they can improve, overcome that one, and so on. So is basically, although ML come very far, we still don't know how exactly deep neural network is training. So if we don't know how training nets actually work, how do we make any real progress? So basically, understanding the output of every neural network or every hidden layer is very, very important. Last year, we got one project from the industry from Bangalore, just to visualize the output of every hidden layer. Okay, one of my MTech PG student was working on that one, and we could basically visualize this output of every hidden layer and so on. So definitely it will be really useful for understanding what exactly is happening inside this deep neural network and so on. So my appeal is that you try to understand the basic concepts and then the working of deep neural network in this one. Then the fifth challenge is that, you might have observed in your this one career also, most of the people are teacher also, or when studying also, there were some students who can learn very quickly, right? So once they read, and okay, they don't need much revision or like that. So like as a one-shot learning kind of thing is there. Some of the students are there who requires a lot of revision, same topic they have to revise several times, and then after a lot of revision they come to somehow close to the person who is one-shot learning or like that. Now our neural network is just like as this person, okay, who requires a lot of this one revisions or iterations for learning, and then after that it comes to the level of this one expectation or something like that. Now, can we have a neural network which will learn like as a one-shot learning? See, if it happens in the human being, it will definitely happen in the neural network also. So only thing is that it is our challenge as a researcher, it is our challenge to develop the neural network which will learn on the one shot as well as on a very less number of, see, when you're talking about the deep neural network, in the deep neural network, basically for training purpose, you need lot of samples for training purpose. So sometimes it may happen that the number of samples are not available, so very few samples are available, and then this one. So in that case, you have to do the augmentation, and then you have to go with this one. So can we develop the neural network which will work or basically get trained with only one iteration, or which will work basically this one on very small database or something like that? So that is the need of our basically. So currently unable to achieve the one-shot learning, and traditional gradient-based networks need large amount of data to learn iteratively. So basically, gradient means basically we are trying to minimize the error between the actual one and the required one. So this actual one and ideal one, so we are trying to minimize this difference. Is nothing but the gradient based error we are minimizing in current neural network, and then we are iteratively. So find a way to enable neural network to learn using just one or two examples, means samples are also less, and also iterations will be very quick, so that you'll get the quick learning, and then time will be saved, as well as you don't need much samples for learning and so on. So because this is happening in a case of human being. So some of the human beings are really intelligent. Okay, if they see one thing at a time, they can remember that one, or if they read that thing once, they remember that thing. Means there is definitely their neural network is really strong neural network which learns very quickly. So we need to basically develop the neural network such that which will learn very quickly, like as an intelligent human being or something like that. Then sixth challenge in the neural network, or basically artificial intelligence, is that I told you that there are supervised learning approach, then unsupervised learning approach, semi-supervised learning approach, and deep learning approach. This one, reinforced learning approach. Now this deep neural network is used in supervised approach, it is used in unsupervised approach, but very few cases it is used in reinforced learning approach. So definitely the maximum use of this deep learning in reinforced learning will enhance the capability of robot, or gaming AI, or decision making, and so on, online decision making, and so on. So deep reinforced learning, we can say that, will enable ML to tackle harder problems and so on. So need to basically integrate the deep neural network with reinforced learning. So that is the need of our. Then seventh challenge of this area is that semantic segmentation. See that presently we are segmenting the this one like as an individual object or like that, but human being perceive the object very high level way, and so on, whereas machines understand the object with a very low level. So when you are segmenting the object, which will have the interrelation and so on, which will identify the interrelation among the object, and then find the meaningful information from that one, that will be really useful for scene description or scene analysis and image classification and so on. So semantic segmentation is one of the challenging area, and deep neural network will be really useful in that case also. Another challenge which is very, very important in this field is that you may have heard that data which is used for deep neural network is very huge data is required. Okay, millions of images are there, millions of samples are there, and generally Kaggle data is widely used by many researchers because a lot of repository is available there. So that data or samples are either in the form of audio, or basically one-dimensional, or images like as a two-dimensional object, two-dimensional, and so on. So most of the deep neural networks are either trained on single dimension or two dimension. But I haven't come across that is means your deep neural network or machine learning algorithms are trained on the video. But you know that, so for example, if I explain something about some incident with the help of words, that is nothing but the speech. So if I explain that one, you'll not get much information. You'll get only idea of that one. But if I show the picture of that by taking the photograph, you'll get much more information, because image speaks thousands of words, right? So there is a lot of hidden information. Everybody will interpret that information in different way and different perspective and so on. So a lot of hidden information is available in the image itself. So instead of speech, you should go for image. Okay, because a lot of hidden information is available. But instead of that one, if I have a 1 minute video or 5 minute video of that incident, you'll get the complete picture, one-to-one relation, and then you can do the analysis of mob and situation and so on with the help of that video. Means video speaks thousands of sentences. A lot of rich information is available in the video data. Now, if this rich information is not used for training purpose of machine, then how machine will become intelligent? Because human being generally capture the image, information in the form of video. Our eyes capture the information in terms of video, and our brain interprets those videos, and then we infer the information. So if our brain does that one, if our eyes does that one, then why not to use this videos for training the neural network, or why not to use the sample videos for training the deep neural network, which will really make a big difference. So there is a basic need for utilizing the video training data set instead of only static images, and allow machine learning system to learn by listening and observing dynamic world. So video is nothing but the dynamic world information. So for better result, like as a human being does, so why shouldn't the machine be enabled to do the same, so like as the human being? So next challenge is that basically developing the this one deep neural network or machine learning algorithm which will utilize the video for training purpose, right? Then object detection. See, object detection is still considered as a hard problem, hard for algorithms to correctly identify, because image classification and localization in computer vision and machine learning are still lacking. Okay, so definitely in this correctly identifying the object, classifying those in complex scene is one of the challenge. So research efforts in this area are needed to interpret the scene correctly and so on. The 10th challenge in AI technology is about privacy concern. See that nowadays everybody is having, like, even in your mobile phone there is a Google Assistant. So we generally ask, hey Google, give me this information, or like that. And then this Google is so your camera is there, your this device has a microphone, this device has a camera, and so on. And then this Google Assistant is also there to help you to find out the answer and so on. So Google Assistant is there, then Amazon's Alexa is there, Apple Siri is there. So all these are the digital assistants which are there for helping the human being. So these digital assistants are making use of camera, they are making use of microphone and so on. So they are continuously capturing all those information, and we are keeping all those digital assistants with us, maybe in the bedroom and then your private room and so on. Now, can you give a guarantee that whatever the information which is captured by this digital assistant will be really secure? Whether it will not be used by that company for commercial purpose, or your this one privacy will be at threat or something? Can you give a guarantee of that one? So it is a really question mark, and that's why people are some of the people are really hesitant to use this digital assistant, because there is no guarantee that your privacy will be maintained or like that. Okay, so in future, because as I told you that most of the device, or basically human being, will be connected with at least 25 devices. So your whole information will be available. So AI will dominate in our lives by incredible improvement in healthcare, education, public safety, etc. And because of ability of AI tool to work quickly and accurately to collect and analyze these quantities of data, or availability of huge personal data, our question arises how we can ensure our privacy, or chances are that our private information may be used inappropriately or for commercial ends. So these smart assistant, Google Assistant, the digital assistants like Apple's Siri Assistant is there, Amazon's Alexa Assistant is there, or Google's Assistant is there, and so can be extremely useful tools nowadays, but also have a large degree of insight into the places we go and the things we do. And then we don't know exactly whether that data is really appropriately used or inappropriately used by those companies, and whether so for this reason many people are already hesitant to use this kind of devices, concerned that the companies behind them could use or sell their personal information for advertising or inverse situation also, right? Then so these are the 10 different challenges which we have studied. Now, what is the future of machine learning, or what is the future of AI? In what way we are going to going, and so on. So first thing is that for searching anything we use Google, right? And this is based on text. This is based on your query and all like that. Okay, and whatever the result you get, those results you get either in the form of text, that is in the form of video, that is in the form of audio, that is in the form of images, and so on. Some of the retrieved information is not really tuned up you with your query or something like that. Now, what we want quick result, we want the accurate result. Now, quick and accurate result, definitely for this, machine learning algorithms will really helpful for getting the personalized fine-tune like that one. Machine learning will really help you to get more correct result and accurate result and quick result for fine-tune personalization also. So you'll get the better search engine experience, therefore neural network and deep learning and so on. So those several algorithms are available. So still we need basically a good one. So it will be there. Then another thing is that evaluation of data teams. See that there are certain trends in how machine learning is being used today and how those cases will evolve in the near future. Okay. So machine learning will be one of the foundational tools for developing and maintaining the digital application in coming years. Okay. So information technology or data teams will spend less time in programming. See that in the future, it may happen that most of the artificial intelligence technology or machine learning technology will be having a capability like that. If you narrate them a situation, they will write a code for you. So you don't need really a software engineers for writing the code or for engineers for doing the coding. Only thing is that you have to frame the problem, give the specifications, and then according to your specification, according to your problem, codes will be written automatically, and then you will get the no code environment in future. Already in the software industry, it has been started work from home, and then in the future it may happen that codes will be written by the machine itself. Then see that means it will be really challenging, and this may going to happen. So machine learning will become just another part of software engineering in future, and the open source frameworks like as a TensorFlow or Keras or PyTorch have not only standardized the way people implement machine learning algorithm, but also remove the procedure prerequisite for doing so. So even you don't need a expertise in coding or like that, but you should have the expertise in solving the problems and so on. Okay, so no code environment may come in the future. Another thing is that quantum computing is another area. See, most of the PG section or even in AICT, they have introduced one subject in model syllabus about the quantum computing. So this quantum computing will really help for developing the hardware, which will be really faster. Processing power will be very, very high, and accelerated learning will happen with this one, and it will increase the capability of your processor or if your machines. Now if your machines are powerful, definitely it will be useful for artificial intelligence or machine learning algorithm to handle the large amount of data or big data and with very quickly. See, the things which are you are doing for in one day will be done in 1 minute in future with the help of this quantum computing. So the integration of quantum computing and AI will revolutionize the things in future, and which will be really helpful in healthcare as well as medicine, where a lot of data is there, a lot of complex problems are there, and complex competitions are involved. So high this one integration of computing into the machine learning will transform the field, as we will see the faster processing, we'll see the accelerated learning and increased capability of machines and so on. Then sixth thing in the future, it may happen that all the retail industries will replace with AI technology and robots. Already this Amazon company has operated the first high-tech grocery store in 2018. They have started, um, which will not require a traditional checkout to the public. So automatically it will be done. So just you go and pick up, and then this one automatically these shelves will be restored, as well as your billing will be done automatically, everything will be done automatically. And then even in 2020, Walmart, another one, okay, they have introduced thousands of robots at its workplace to manage the inventory, scrub the floors, and keep the product shelves in order and so on. So in future, your this supermarket will really become a very smart supermarket, and then everything will be very efficient and so on. Then another thing is that your healthcare facility will be more accurate, and because so human being will be connected with several devices at a time. Okay, so automatically your data will be recorded with your smartwatches or sensors, and then this information will be given directly to your personal doctors, it will be given to the police, it will be given to the hospital technician, it will be given to your relatives, and then emergency systems will be supplied to you for giving you services and so on. Or your homes will be really smart homes, your infrastructures will be really smart infrastructure, smart hospitals will be there, and then you will get basically all these services very quickly. And for that, definitely a lot of data will be there, and AI technology will help in this health related issues for diagnosis purpose, for providing the services and so on. So you'll get more accurate healthcare services in future. So now for studying this subject or this one, where you will get the material. So definitely the material which is available in the form of journal papers, research journal papers, or conferences and so on. One thing is, I'll tell you that there are several journals available. Okay, every day new journal is coming, every day somebody is organizing the conference or like that. But question is that which one we should refer. Okay, so this one, there are standard journals available. So always look for the better. Don't go for the garbage and then get trapped in that garbage for like that. So if you want to be really on the front side of this, you want to be a leader in this research and so on, so you have to have the access of the top material of the top journal and so on. So see that I'll tell you that there are several conferences which are organized by many research, many industry, this one institutes or universities and so on. Kind of mushrooming kind of conferences and so on. Multi-track conferences are there and so on. But attending such conferences will be of no use and so on. So you have to plan such that, okay, your paper should be accepted in the top conference, where the people from top industries, people from the top universities, great researchers comes to deliver the invited talk, so that you will understand what exactly happening in the what are the recent trends in the industries, what are the recent trends in the top universities and so on. So The conferences like IEEE conference, computer vision and pattern recognition, CVPR. This is the top conference in this AI field. Okay, getting paper published or basically accepted in as a poster form is also prestigious in this one, because researchers from top companies like as a Google, Microsoft, Facebook, and then Adobe, and so on. So all those top players, researchers comes to participate in this conference, or researchers from the top universities also participate. So everybody's dream is basically to publish the paper in CVPR or ICCV, that is International Conference on Computer Vision, or International European Conference on Computer Vision, ECCV, then International Conference on Image Processing, ICCP, then International Conference on Pattern Recognition, that is ICPR. So these are the top players or top conferences where good material is published. And see if your paper get accepted in this conference, even this one, poster paper, there are chances that enhanced version of this paper will be published in IEEE transaction. Already we have done, means I have published though papers in ICIP and this one abstract of that research, and the enhanced version of that one is published in IEEE transaction conference, IEEE transaction journal, and so on. So my basically appeal for you people is that target for the good conferences. Now there is one more conference from Indian side, that is called as the ICVGIP conference. So ICVGIP is nothing but the Indian conference on graphics, image processing, and vision. Okay, ICVGIP is something like that. So this conference was started in 1995 by my Professor B.N. Chatterjee, was a founder member of image processing in India at IIT Kharagpur. He started research in 1972, and then a lot of many researchers or great professors worked under him, or even actually the professor of this one, IIT Bombay director right now, he's also the student of Professor B.N. Chatterjee. And okay, so he started one conference in 1995 that originally its name was ICPIC conference, and then it was basically for image processing, computer vision, pattern recognition, and AI related technology, and so on. In 1998, this name was changed. Instead of ICPIC, it was changed as ICVGIP at IIT Delhi by Shantanu Chaudhary. And then it was decided that this conference will be organized after 2 years, and then it will be a rotation. It will be organized in IITs, but it will be by rotation. Like for example, now this year is at North, next year it will be at East, then after 2 years, okay, after 4 years it will be at South, again after 6 years it will be at West, like as Bombay, and then again it will be at North, and so like that. So this kind of circle they have formed, and the quality of paper published in this conference are really good. So my suggestion will be that you should attend that kind of conferences to get the good material, to listen the good people, and so on. So this is all about the conferences. And then this one, journals like as IEEE transaction on PAMI, pattern analysis machine intelligence. So this is the top journal where you find a good material, a quality material or quality paper. Then IEEE transaction on neural network, IEEE transaction on image processing, IEEE transaction on multimedia, IEEE transaction on medical imaging, or journal of machine learning research. Then so these are the IEEE journal. These are the Elsevier publication journal. Then this pattern recognition is also Elsevier. Image vision and computing is also journal. Computer vision and image understanding, then pattern recognition later, and SIEM computer service. So these are the top journals where you'll find the material related to this area, and these are the top conferences on this one. And apart from that one, definitely you have to learn the subject from this. Good books are available related to image and vision, or this one neural network. There are good books for this one deep learning. Also, there are good books available, and so on. So try to learn the subject very thoroughly, understand this one. One more thing I'd like to tell you that this semester I'm teaching computer vision subject to the MTech Artificial Intelligence, and since this is online kind of things, so I thought that okay, anyway I'm teaching to the student online, and then I'll record all my sessions, and then I'll make it available to the all people, those who are interested. So this second semester started for MTech. It has been started since 17th of May, and already 5 lectures are over. So whatever the lectures which I have delivered, I have recorded that one, and those lectures are made available on my YouTube channel. So this is particularly for computer vision side. So if somebody is interested in computer vision side or learning that subject, so they can follow my channel also. Right now, 5 lectures are over. So every week there will be 3 lectures. So I'll immediately after my lecture, I upload that videos on YouTube, and you can learn, those who are interested in basically computer vision and so on. So like that way, there are other resources available, and you can learn the subject and so on. So thank you very much for the first session. You can ask if you have any questions on this one, you can ask, and then after that we'll go for the quick session of our second one. So over to you.
Yes, participant, any questions you can ask. You can put into the chat box also.
Yeah, I can also answer the question of chat box.
And you can also unmute yourself and directly ask this.
Channel name is basically Suraj. My channel name is just Manesh Kokre, so you can follow that one. I think Bhuvan Atul. Okay, so my
Video
channel
was,
name is my name itself. Okay,
yes.
and
Also on
Bhuvan,
LinkedIn also available.
yeah, it is available on LinkedIn. It is available on this one. On my Facebook group also. Bhuvan has asked list of journal name. Already I have given you this one. I'll share the presentation if you want. So that journal, this one. Okay. Jangam has asked about, okay, sir, what about the TensorFlow? So see, this is the architecture which is proposed by Google, and then you need to learn those things. Yeah. So every architecture is different. So RNN is there, TensorFlow is there, and so many deep neural network. Okay, so that you can learn through the deep learning algorithm. Anything else? Okay, Swapnil has asked, how do we apply transfer learning on image data? Okay. See, all those deep learning algorithms or transfer learning or this one, you have to basically explore RNN, transfer learning, and this one, TensorFlow, and so on in the deep learning architecture. Okay, because everything is different. If someone wishes to work in medical imaging, a real with ML like as a corona disease prediction with images, what do you do if data is not available? See that, Tanita, first thing is that for doing any research, you need a data, and you have to have the collaboration with this one. Already researcher has started to grade this. See, there are grades like as up to 27, 0 to 27 grades are there, and then this is basically recorded through the X-rays which are of lungs and this one. So this one, already researchers have started working on that one, and they have collaborated with the hospitals to get the data. Without data, you cannot do the research basically. Okay, so I hope that basically data is very, very important for doing the research. Okay, so researchers have already started working on this one. One thing, okay, who is this one? Bhuvan has asked me, ResNet, ImageNet, VGG16 are different from each other. Yes, every architecture is different in some or other form. Okay, that's why different names are there. Okay, and their applications are also different. Okay, you cannot use that. Okay, the same architecture for different applications. So you have to look for the details of those. Okay, I hope that one I have answered. Sure. Then, sir, kindly suggest book for proper study. Okay, I don't know who has asked this one. Proper study means, see that as I told you that in under the this one umbrella of artificial intelligence, you have subjects like as a digital image processing or visual data analytics is there. You have subject of the artificial neural network is there, deep learning is there, computer vision is there, and so on. So for every subject there are excellent books available. I'll tell you that for image processing there is a book like as a Gonzalez and Woods book is there, or Ramesh Jain's book is also there, which is really good book for understanding purpose. For neural network, Zurara's book is also a good book, which is old book. So like that way, you have to basically find for computer vision, okay, which I teach the subject. For that computer vision subject, book of this one, professor from Iowa University is there, Milan Sonka. So his book is also quite good book for computer vision for understanding purpose. So like that way, speech processing, you have to ask the expert of this, because I'm not a speech processing expert. I work really in the domain of diabetic retinopathy, medical image processing, or I work in the computer vision. I have designed my own wavelets also. So I'm more in that side, and machine learning and computer vision. So like that way. For speech processing, natural language processing, definitely you have to talk with the experts, which book is really useful for them. So really means for beginners, they have to start from the books, study that one, or tutorials. Online courses are there, courses on Coursera. For machine learning or deep learning, Andrew NG course is also good course. So those interested, they can do that course for machine learning of Andrew G from Stanford University. So that is also good course available. Or the courses conducted by various industries also. Recently, NVIDIA course we have done on this one, computer vision and machine learning in the last, I think 15 days back only, we have attended that course. That is also good course for this one. So either you study from the online courses or books and so on. Okay, Swapnil is, I am currently working on corona detection using X-ray image. The accuracy is nearly 80%. So are there any techniques available that can improve the accuracy of my model? See, Swapnil, one thing is that this corona detection with the help of machine learning or this one AI technology is a new problem right now. So definitely, whatever the model which you have used, I don't know what kind of model you have used, that I don't know. Okay, you have to study that one. First thing is that you have to study the pattern of that corona, how the infection is there, and then because these are X-ray images and so on. One thing is that you can try with different models which are available in deep learning. And then you have to not only that one trial and error, you have to identify also why you are getting better result or why you are getting the poor result. So my suggestion right now, okay, whatever the model which you have used, okay, let us keep it with you. 80% accuracy you have got. Now use another architecture of deep learning and see what kind of result you are getting, and then from that you try to infer that why you are getting better result with another model, and why not with this model, and so on. So like that way. So definitely you will get more accuracy. Even 99% accuracy you can achieve. Okay. Okay. Anything else? Okay. Thank you, Swapnil. So shall we start the this one?
Yes, sir. We'll go.
We'll go for okay. We'll go for linear regression. That is the one of the case which I'm going to take. Is it visible now?
Yes, sir. It is visible.
Okay, fine. Basically, I told you that in machine learning, there are four types of machine learning. One is supervised learning approach. Another one is unsupervised learning approach. Then third one is semi-supervised learning approach, and fourth one is reinforced learning approach. So in supervised learning approach, priori information is known. Okay. In unsupervised learning approach, priori information is not known. Okay. And then in reinforced learning, you get the information after you get the result. Okay, means you get the feedback after you get the result, and so on. Now, this supervised learning approach is further classified into classification problem and regression problem. So classification problem is simple, like for example, your output is a discrete value, like as this is one class, this is another class, and so on. So like that way you have the discrete values, and generally for image classification, object recognition that is used, and you know that there is also a training phase is also there. So your algorithm will be trained with the standard algorithm available, and then once your algorithm is trained, after that testing will be done, and then after that validation will be done, and then finally your algorithm will be deployed. So this is in case of this one classification problem. Another problem in case of supervised learning approach is linear regression. Okay, so see that in linear regression also you have priori information available. I gave the example of linear regression, means basically you are using that one for predicting something in the future. Like what will be the, as I took the example of what will the load, electric load requirement of my own institute after 5 years or 7 years, and then how I'm going to do that one, because I have the priori information available, like what is the previous 5 years data. That data is in like as hourly data, that data is daily data, that data is weekly data, that data is monthly and yearly data. So from that pattern, okay, I'll develop the algorithm which will study that pattern, and based on that learning, I'm going to predict that what will be the load requirement of that one. Or for example, what is the stock market prediction? Like for example, if you know the previous stock values of some companies, and then if you know the trend, and then from that priori information you can predict what is the this one stock value of this company, what will be the stock value of this company, or something like that. I took the example of this one of my research, this one research group is working on this one survival prediction of the human being. So this collaboration with Tata Memorial Hospital at Bombay, and then we have the database of this one brain tumors of several patients, and then ground truth is marked on that one, and then the algorithm is developed basically which will basically identify the region which is affected, and then how much is the growth, and then based on that one, how many years this person can be survived after the brain tumor and so on. So prediction of that one is possible with the linear regression and so on. So here linear regression output is basically a continuous value. Okay, and you have to develop the model of that. Now this model is basically what kind of model is there? So model depends upon your dimension of the features. Like for example, if number of features extracted, you have extracted like as only this one, two-dimensional features are there, then simple line equation will be fine. If it is three-dimensional, then plane and so on, then hyperplane and so on will be there and so on. So this model should fit such that, okay, it will be very close to the actual value. Otherwise, suppose for example, if you are predicting that tomorrow there will be rainfall, and then if it is not coming, then this model is a useless model or like that. But okay, your prediction should be very close to the actual one. So that is the aim of linear regression. Now see that regression is a statistical procedure that determines the equation for the straight line that best fits a specific set of data. So means basically we are finding the straight line such that in case of two-dimensional data, we are finding the straight line such that it will best fit the specific set of data. Now see that here, as I told you that this regression can be used for stock market prediction or weather forecasting or this smart city growth prediction, or basically your survival prediction or customer prediction and so on. So like that way. So it is used for prediction purpose, and its output is continuous value. So any straight line, you know that straight line equation is very well known. We have studied since 8th class itself, 7th class itself. So which is given by y equal to mx plus c, where m is nothing but your slope of that straight line, and c is nothing but your intersection with the y-axis. So where y is the output and x is basically the input. Now what is known here? Known is your x value, and from this x value you are going to predict the y value. Okay, so any straight line can be represented by the equation from y is equal to bx plus a, where b and a are constant, and the value of b is called as the slope constant, and determines the direction and degree to which this line is tilted. So this predicted line. Okay, so the value of a is called as the y-intercept and determines the point where the line crosses the y-axis, or sometimes it is called as the bias also. Right now. Basically, whatever we are predicting this line or linear regression, this straight line, this should be very close to the actual data point or actual values. So how we can say that it is very close? So when we compare the one-to-one data points, so the distance between the line predicted line point and the actual point, this distance should be as minimum as possible. So how well the data set of data points fits the straight line can be measured by calculating the distance between the data points and the line, and the total error between the data points and the line is obtained by squaring each distance and then summing the squared values. Now see, ideally this distance should be 0, right? So the regression equation is designed to produce the minimum sum of the squared error. So this is the regression equation. Like for example, you have this x values. Okay, x value is known, and you are predicting this x value from y. And these are the actual data points, right? These are the actual data points. Now you have designed the line equation such that line equation is like this. Now this line is the regression line, or equation of line. And then you know that this equation will be equal to y equal to mx plus c. So x is basically your known things, and you are predicting y value from this one. So m will decide the slope of this line. Now how well this line fits the actual data points. So this is decided by the error. Now what is the error bit of this point with this one, this line? So this point and this distance is nothing but the error. So this should be as minimum as possible. Now what is the error? So this is the error between this point and this line. This is the predicted one and this is the actual one. Then this is the predicted one, this predicted one value, and this is the actual one. So this is the distance, this is nothing but the error. Okay, so like that way you have to calculate the error for every point with respect to line, and then this error should be as minimum as possible. So you have to change the angle, or basically you have to change the slope such that it's not possible. It's not only the one possible. You can have the line like this way, you can have the line like this way, you can have the line like this way, and so on. So multiple options are there, but which one you have to choose? The line which will give you the minimum error. Okay, so that line equation you have to find. So given an input x, we'd like to compare the output y. So for example, predict the height from the edge, predict the Google's price from the Yahoo's price, or predict the distance from the wall from the sensor, and so on. So linear regression is given an input x, we would like to compute an output y. So from given value x, we are going to find out the value of y. And in linear regression, we assume that y and x are related with the line equation. And line equation is nothing but the standard equation, which is given by y is equal to wx plus sigma. And this is nothing but your this one, slope and then intercept. So w is a parameter, and sigma represents the measurement or other noise parameter or bias point, and so on. So like that way. So we have to find this equation such that error will be as minimum as possible. Now see that. So this is what we are going to predict value, and from what? This is the observed values. So this is the observed value. So from this observed or previous data, we are going to predict the future data. So like that way. So see that if x goes on increasing, what will the value of y as go on, and so on. So from the observed value, we are going to predict the value, okay, expected value. And then for that, we need to find out the value of w. That is nothing but your this one, slope. So where w is a parameter and epsilon represents the measurement or other noise, and so on. So in linear regression, see that yi is equal to this one, wx. So this value should be as minimum as possible. So this value should be as yi is basically the actual output, and then wixy is the predicted output. So this actual and predicted one, this error should be as minimum as possible. So square of error we have to minimize in this case. And how it is possible? So our goal is to estimate the w. We have to find out the value of w. Okay, from where? From the training data set. We know, see, in training data set we have the this one prior information about the class and the patterns. So we can say that xi is the pattern and yi is nothing but the class. So this information is available with us, and from this training samples, okay, we have to find out the value of w of that equation such that this error will be minimized. So this square error will be minimized. Now how to minimize this square error? So we have to use that one by using simple mathematics. So just take the derivative with respect to w. So partial derivative with respect to w, that will be equal to, see that this equation, we are taking the derivative with respect to w, and then you will get this equation after taking the derivative. And if you compare that one with logistic regression, so it will be like this. And then here wixi is the predicted value, and here in logistic regression also it is p is the predicted value. So this is very similar to the regression, the equation. This is prediction. And then to optimize, see, we have to find out the value of w such that this error will be as minimum as possible. So if you equate that one equal to 0 and find out the value of w, you will get, see that this equation, after taking the derivative, you got this equation from this equation, and then equate that one equal to 0. So then after that you simplify this one. So you'll get this twice summation or I xi yi minus twice summation w xi and this is equal to 0. So if you simplify that one, you will get this equation, and then finally from that one you can calculate the value of w. So w is nothing but summation or I xi yi divided by summation or xi square. So this value should be such that it will minimize the error, predicted value error, and so on. So that is what we have to do. Now see that in regression example, if w is equal to 2 and then record w is equal to 2.03 and then standard noise is 1, you got, suppose for example for this data you got this line equation, and then if you change the value of w, you'll get this line of equation, and so on. So like these are the these things. Now another thing is that how to calculate the bias term, like intercept of this one. So you have to find out the way we do it in our simple mathematics to find out the y-intercept and find out the slope of that line. So the same mathematics we have to use in finding the bias term also. So that is nothing but the intercept is nothing but the bias term, and then it means it is not like that always your linear regression equation will pass through the origin. It may pass through the with some y-intercept, or it may pass through this one or like that, or it may pass like this way or something like that. So you need to have the value of w0 also, you need to have the value of your m also, and this is calculated by using simple mathematics, which is generally we have studied that one in our earlier mathematics. So w0 and this one w is very, very important for calculating the linear regression equation. Now another thing is that sometimes it may happen that your output depends not only on one variable, but it depends upon the several variable, like as a output depends on like for example, you'd like to estimate the age of the person. Now estimating the age of the person, like for example, it depends upon the height of the person, it depends upon the weight of the person, it depends upon the face of the person, or like that. So you're estimating the age of that person. So y is age, and then you're detecting okay, based on what one. So this height, age of the person depends upon the height of the person. It depends upon the, like for example, weight of the person. It depends upon another face or like that. So there are several variables on which this y value depends. So x1 is one variable, x2 is another variable, x3 is third variable, and so on. Or sometimes it may happen that the price value of one company depends upon the price share value of other companies' share value. Like for example, share value of Google depends upon the share value of Microsoft, share value of Adobe, share value of your Facebook, and so on. Means share value of Google depends upon X1 is Google, this one Microsoft, x2 is your Apple, x3 is your, suppose for example, Adobe, x4 is this one. So x1, x2, x3, these are the variable on which your y value depends. So this kind of regression is called as the multiple regression. Means you are predicting the value of share of Google based on the value of Apple, based on the value of your Microsoft or Adobe or so on. So this can be extended like as a simple linear regression. So multiple regression is more than two predicted variables. So in the same way that the linear regression produces an equation that uses the x to predict the value of y, multiple regression produces an equation that uses two different variables, x1 and x2, to predict the value of y. So the equation is determined by least square error solution, and that minimize the square distance between the actual y. So whether it is a single regression or multiple regression, the aim of that predicted model should best fit to the actual data. So this best fit means what? Error should be as minimum as possible. Then and then your prediction will be very close. Future prediction will be very close to the actual data. So the equation for the multiple regression will be as this y cap is nothing but the output. This depends upon the value of x1. This depends upon the value of x2. This depends upon the slope b1 which is associated with x1, slope b2 which is associated with x2, and so on. So the ability of multiple regression equation to accurately predict the value y value is measured by first computing the proportion of y-score variability that is predicted by the regression equation, and the proportion that is not predicted, and so on. So multivariate regression example I took, same example. What if we have several input like as Yahoo stock price for Yahoo, Microsoft, and eBay for the Google's prediction task. So you can minimize, basically you can model that one. This becomes a multivariate regression problem, and then output of this Google, it depends upon the value of Yahoo, it depends upon the value of Microsoft, it depends upon the value of eBay or other. So basically Google's price depends upon the Yahoo's price, it depends upon this W is this one, not W, it is X1. So this should be here. Okay, this arrow should be at X1, this arrow should be at XK, right? Not W1 and WK. So Google stocks price depends upon the stocks price of Yahoo, its stocks price of Microsoft, and so on. So even if you extend for multiple, equation will be like this, and so on, right? So now this is linear. Equations are linear, which follows the superposition principle, and that's why it is called as the linear regression. But sometimes it may happen that your equations are not linear equations; they are non-linear, or they are using some kind of this one. Functions which are linear convolution functions, which are non-linear convolution functions. Then in that case, this one regression is called as the nonlinear regression. And one of the simple example of nonlinear regression is if you have studied this one. Um, one classifier is there, which basically uses the nonlinear regression model to separate out the mixed features into the so with simple suppose for example you have the data which is really mixed of one class with another class. Now if you use any kind of linear this one, there will be a lot of misclassification and error will be there, and then simple model will not work in that case. But if you have studied the support vector machine, in support vector machine what happens, basically you have the kernel function like as a Gaussian kernel is there, which basically scales the data by using Gaussian function, and then this will separate out the mixed model or mixed data into this like by using Gaussian function. So top class will be like this and bottom class will be like this, and then you can use the decision boundary which will separate the one class from the another class. But with simple one linear one, it will not solve the problem. So in nonlinear, you have to use the nonlinear functions which will separate out the mixed data, and it will improve the accuracy. So this support vector machine, where we use the nonlinear Gaussian function as a kernel functions, that is another example of your nonlinear regression. So nonlinear basis functions, how we can interpret them? So by using the basically functions like polynomial function, Gaussian function, or sigmoid function. These kernel functions are generally used to separate out the difficult problems which are there in the linear one and makes it simple and improve the accuracy. So that regression where nonlinear functions or basis functions are involved, that is called as the nonlinear regression. And so basically overall regression is used for predicting the values or future values, and this is based on the past values. So past values are represented with x terms and future value is represented with y terms. So this one future values may depend on only one variable, that is called as the simple linear regression model, and if it depends upon the multiple values of past, then it is called the multivariate regression, and if it depends upon the nonlinear values, then it is called as the nonlinear regression, and so on. So this is all about the regression case and so on. And if you have any questions, I'll be happy to answer those questions. Okay. So over to you.
Yes, if you have any questions, you can put in the chat box.
Thank you, Rupali. Okay, can we use the term semi-unsupervised instead of semi-supervised? Yeah, you can. Vinod. Right. But okay, Radhika sir, how to fix the equation for hyperplane in SVM? Okay. See that, Radhika, you study the output, like for example, see, after all in SVM, you are consider one versus all. So, okay, if you study the concept of one versus all, you will get the answer of this, how to fix the equation for hyperplane in SVM. Okay, because after all, SVM is two class problem. So when there is a multiple class or multiple this one features are there, so definitely you have to consider one at a time, and then others will be this one. Mm, considered as one class or something like that. So in the same way, you can extend this one.
Okay.
Okay. Sufyan, thank you.
Okay, so I think no questions.
Okay, so I'll just leave my contact details to you if somebody is having any of this one. Thank you, Anita. My contact details are like okay, mbkokre@sggs.ac.in, and my phone number is 9421474393. Okay, so these are my contact details. I'll be happy to be in touch with you. So thank you very much.
Thank you, sir,
Thank
that
you.
you have
Thank you.
nicely explained all the things. And thank you for you took the time out of your busy schedule and assured with your wisdom of knowledge. Sir, we are truly humbled with your presence, sir. Thank you. Thank you once again. So I
Thank you very
request
much.
our HOD Yogesh Risodkar, sir, please offer a vote of thanks to sir. Risodkar, sir, please. Risodkar, sir. Risodkar, sir. Maybe some issue their network side, sir, at Risodkar, sir side. So on behalf of Sandip Institute of Engineering Management, Nashik, I would like to thank you, sir, for your dedication toward this session from the phase 1 to phase 2. So really participant will enjoyed your sessions. Uh, so thank you once again, sir. And in the future also, I hope the same cooperation from the your side, sir. So thank you, sir.
Sure,
Thank
sure,
you so much.
sure, sure. See, all the best to all participants. Thank you.
Thank you, sir.
So,
Welcome, sir.
okay. So shall I take a leave?
Yes, sir. You can take.
Okay. Thank you. Thank you very much.
So participant, the next session will be at 3 p.m. sharp. The next resource person is Dr. D.B. Kulkarni, sir, from Walchand College of Engineering, Sangli. So he will guide through clustering technologies and some more problem analysis also. So we will meet at 3 p.m. With Dr. DB Kulkarni sir. Okay. So yes, I'll share the link of feedback and attendance here, so you can fill the feedback as well as attendance.